everyone. So now that we've learned those trigonometric ratios, we're going to use them to actually solve for something. And in this video, we're going to solve for angles. Before we get started, I wanted to show you that SOHCAHTOA thing one more time, because remember what I said, there's 6 trigonometric ratios, but we end up using the first 3 way more often, mostly because they're already on our calculator, and we're going to be using our calculator a lot today. So the acronym to memorize these are SOHCAHTOA, where SO stands for sine of theta is equal to your opposite side over your hypotenuse side. The CA part stands for cosine of theta is equal to your adjacent side over your hypotenuse. And then the TOA part stands for tangent of theta is equal to opposite over adjacent. Once again, you don't have to memorize these. I'm going to always give them to you, but you'll end up using them so often that you actually might end up memorizing them. So these are the three ratios that we're going to be working with on this video, and what we're going to be doing is solving for angles. So sometimes you get this right triangle and you have a couple of sides, but you want to find the angle that's associated with it. And to do that, we have to use trig. So let's get started with the first example. The first thing you're always going to do is label your sides opposite, hypotenuse, and adjacent. And remember, you need to determine what angle you're working with. And so the angle that we're going to be working with on this one is the theta, or the question mark that you're trying to solve for. So for example number 1, to label our sides opposite, hypotenuse, and adjacent, this side goes to opposite. Then this side would be hypotenuse, because remember, it's always opposite your right angle, and then your adjacent is the one that's left over. Well, now that we have the triangle labeled, what we're going to do is look for what we have and what we don't have. So we have the opposite side. We know the opposite side is 27. And we have a hypotenuse side. We know it's 45. And we want the theta. So what we're going to do is look at our 3 equations up top and determine, well, which one has opposite and hypotenuse? Because those are the things that I already have. Well, sine, the equation for sine has opposite and hypotenuse. So I'm going to use that equation that sine theta is equal to opposite over hypotenuse. But now I'm going to replace what I know about it. So I don't know what theta is, so I'm going to leave it as sine theta. But I do know my opposite side is 27, and I know my hypotenuse side is 45. Okay, great. So now I have this equation that says sine theta is equal to 27 over 45. But I don't really care about that like I cared about it in the last video. Instead of getting sine theta, now I just want to find theta. So to find theta, which is the angle or the measurement of the angle, I've got to get rid of the sine. And the way that we get rid of the sine, right now it looks like it's multiplying by theta, but it's not. So you don't divide by sine. Instead, you have to take the inverse sine. So I'm going to write it out here. I'm going to say that theta is equal to the inverse sine, which is shown by sine to the power of -1 of the fraction 27 over 45. Now that's what my answer is, but I'm going to plug that into a calculator. And to get that sine inverse in a calculator, what we're going to do is you're going to press the second button, which is usually up at the top left corner, and then press your sine button. And what should happen is it should say SIN, then a little -1, then parenthesis. So that's perfect. That's exactly what we want to see. And now we're going to just put in the fraction inside the parentheses. So 27 over 45, where that 27 over 45 is all inside the one set of parentheses. We press enter, and I end up with that theta is equal to 36.9. And that's in degrees, so I leave it in degrees. So it's 36.9 degrees. Because we're going to be using your calculator so much, we want to make sure it's in the right mode. If you got something other than 36.9, then it must be in radian mode. You want to make sure that it's in degree mode. So go ahead and pause the video, change it to degree mode. This whole video, you're going to be in degree mode. So you won't have to change it back and forth. And make sure that when you plug it back in, do it again and make sure you get that 36.9. Okay. So let's go to the next example. Same thing, we want to solve for this angle, and the first thing we're going to do is label our sides opposite, hypotenuse, and adjacent based on the angle we want to solve for. So my opposite side would be opposite of the angle that I'm using. My hypotenuse is always opposite of the right angle, and then your adjacent's the one that's left over. Okay, so now once again, we're going to figure out what we have and what equation would work best with it. We have the adjacent side, which is 20, and the hypotenuse side, which is 28. So what equation out of those sine, cosine, tangent equations uses adjacent and hypotenuse? That's cosine. So we're going to use the equation cosine of theta is equal to adjacent over hypotenuse. Now that we have that, we're going to plug in what we know. So we're going to say cosine of theta, because we don't know what theta is, but we do know the adjacent side is 20 and the hypotenuse side is 28. Okay, great. We're almost there, but instead of solving for cosine theta, we want to solve for just theta. So to get rid of the cosine, we do the cosine inverse, which means that my formula ends up being that theta is equal to cosine inverse, or cosine to the power of -1 of 20 over 28. Okay, now that's something we can plug into the calculator. So to do that, we press the second button and then the cosine button and do 20 divided by 28, where that whole thing is inside the parentheses. Press enter, and I end up with that theta is equal to 44.4 degrees. Awesome. Okay, let's go to the third example, which is the same. So we're going to start with labeling our sides, opposite, hypotenuse, and adjacent. So our opposite side would be opposite of the angle we're trying to solve for. Your hypotenuse side is the opposite of the right angle. It's usually the long slanty length, and then your adjacent side is the one that's left over. Then we've got to figure out what we have. So we have your adjacent side and your opposite side. Let me scroll up. Which trig function uses adjacent and opposite? That's the last one. That's tangent. So I'm going to say tangent of theta is equal to opposite over adjacent. And then we're going to plug in what we know. So I don't know what theta is yet. I'm just going to say tangent theta equals your opposite side is 11, your adjacent side is 7. And then we do to solve for theta, we've got to get rid of the tangent. To get rid of tangent, we do the inverse tangent. So we have theta is equal to tangent inverse of my fraction, which is 11 over 7. I plug that into a calculator by pressing second tan, and then 11 divided by 7, close the parentheses, and I end up with that theta should be equal to 57.5 degrees. So this isn't too terrible. Let's do one more example. So once again, we're going to use the angle that we're trying to solve for to label our sides opposite, hypotenuse, and adjacent, which means that this side would be our opposite side. This side would be our hypotenuse side. Sorry, I forgot to write the right angle in there, but this is the right angle. And then the side that's left over is your adjacent side. So we have your opposite side and your hypotenuse side, which means that we're going to use the trig function sine. So sine of theta we know is opposite over hypotenuse. We're going to plug in our opposite and hypotenuse values, which would give me 13 over 21. So we know that sine of theta is 13 over 21, but we don't want sine of theta, we just want theta. So I'm going to take the inverse sine of 13 over 21 to get theta by itself. And we plug that in second sine 13 divided by 21. And I end up with that theta should be equal to 38.2 degrees. There we have it. And this is how we use trig ratios to solve for angles.